Welcome to Study Loop.
So here we're given information that we have a compound with a molar mass of 177 grams per mole, and we're given that the amount of hydrogen is 8 times less than that of carbon. So the mass of carbon in 1 mole to the mass of hydrogen in 1 mole of our compound of interest is equivalent to 8. So here, let's just say we have 1 mole of our compound. So 1 mole of our compound would have 177 grams, which would be equivalent to a certain amount of, let's just say X times the molar mass, the amount of oxygen, plus Y times the amount of bromine, and we'll just take the molar mass of bromine to be 80, plus Z, the amount of, let's just call this the amount of hydrogen, so Z would be plus 1. Then another factor, let's just call it W in this case to be the amount of carbon. So mainly here, these are equal to, this would be equivalent to the mass of oxygen, the mass of bromine here, the mass of hydrogen, and the mass of carbon. So we can use this ratio here to simplify things down a bit. So the mass of carbon is 8 times the mass of hydrogen. So the mass of hydrogen we already have is Z. So the mass of carbon would be equivalent to 8Z. So let's rewrite this. So 177 grams equals X times 16 plus Y times 80 plus 9Z. So mainly here we just have to iterate because we don't have enough information beyond this. And immediately we can see that the amount of bromine we can have can't be over 1, since if it's over 1, it would be equivalent to 160 grams, and that would become too large, so Y has to equal 1. So now essentially we just have to adjust for the amount of X and Z in our equation here. So 177 minus 80, so 97 equals 16X plus 9Z. So mainly here we have to look for possible combinations of values that yield an answer that's equivalent to 97. And one of the easier ways to do this maybe would be plotting a line on the grid in order to determine where it would be equivalent to 97 and for possible combinations. And mainly here we can find that a whole number solution exists when we have X equals 1 and Z is equivalent to 9 in this case. So based on this information here, we can now determine the total amount, the molecular formula. So we have 1 molecule of bromine, we have 1 molecule of oxygen, and now we have to back substitute into our equation here. So the amount of hydrogen is 9, so we have 9 atoms of hydrogen. So the amount of hydrogen is 9. So we have H9 somewhere. And the amount of, so this would be 8 times 9 would be 72. So we would have 6 carbons. So let's rewrite this in either way. So we could get C6H9OBr. And we should finally check if the molar mass is equivalent to the molar mass of our interest. And we find that this is equivalent to 177 grams per mole. So this is our compound of interest.